Review is it's I would do the same thing whether you had the regents or not, right? So the actual regents exam that you guys would have taken was canceled, so you get credit for it as long as you pass the class. You get regents credit for it, just like probably your science last year or
So
whatever.
what does that mean?
It just means it's a graduation requirement.
Oh,
So
I took the math region
Mhm.
year, but
Yep.
it was canceled. And they still gave me the credit.
Yeah, that's it. So that's
Even
what happened with this
I
class.
just passed, but I didn't put it on my.
Yeah, yeah, same thing this year. But still, we still have a final exam, which is going to be like a regents exam, so it's the same sort of thing. So let's start about with talking about science in general, right? Scientific method. So remember, scientists do experiments. That's how we learn things in science, by doing experiments in which we ask a question, we set up a hypothesis, and we test it by collecting data. And looking at the results, we can decide if our hypothesis is supported by our data or if it's not. And like we just said, it's okay if it's not. Sometimes a hypothesis is not supported, and we might come up with a new one, test something else. It's still valuable. It still helps us learn about whatever phenomena we're studying. And so there are some terms, and these are terms sometimes are confusing to people. So when we do a controlled experiment, we want to always just change a single thing at a time. Change one thing. And that thing that we change in our experiment, that's the independent variable. Right? The I looks like a 1 because it's the one thing that we try to make different in our groups. Okay? So do you remember the first thing we did in this whole class, first day?
Slugs.
Yeah, we looked at the slugs, right? And we did an experiment trying to test what kind of food they prefer. That seems like so long ago, doesn't it? We had two different foods. That was our independent variable. We're looking at what do they prefer, which type of food. Or we did the clothespin experiment, right? We either exercise or didn't exercise. We changed that. That was our independent variable. The dependent variable is the data you're collecting, the results. So with our slugs, it was how many little squares of each food they ate. With our clothespin, it was how many times you could squeeze the clothespin. That was our dependent variable. It's the data you're collecting. And you try in a good experiment to keep all of the other things the same, right? We wanted the same size of food with our slugs, the same amount of water, the same temperature. Wanted all those things to be the same. Our hypothesis, there's some key things about the hypothesis. It has to be a statement. It's a prediction. It can never be a question. It can't have a question mark at the end. That's something they sometimes ask, is like, which would be a correct hypothesis? And it has to be a statement. It's what you think was going to happen. Um, so, sorry. We could start thinking about a problem by making some observations. Why does this frog, why is it so colorful? Why does this fly look like a bee? And you probably have a hypothesis, right? Why does this frog so colorful? Probably.
Poison.
Yeah, poisonous animals are often brightly colored. Yeah, that's a poison dart frog, exactly. To warn predators, because it doesn't help if you're poisonous, if something eats you and then it dies, right? Because you're dead. So it's better to advertise the fact that you're poisonous so things don't eat you in the first place.
So it can be very many colors. Some are brighter than others.
Yeah. We collect data in our experiments. Sometimes we put it in a data table. Sometimes we graph it. Okay. So in this example, if we think about the independent and dependent variable, we're looking at age is the independent variable. We're measuring the height of people at these various times.
Can I just look on up there?
Yeah, that's fine. This is really for you to, you could look on, follow on this, or you can just look up here as we're talking. But this is good to study. If there's a topic you're confused about, if you want, some more practice. So let's think about an experiment. Let's say we want to design an experiment that would test the effectiveness of a cough drop. You guys ever take cough drops? Yeah. When I was a kid, I don't know if they make them anymore, those cherry Ludens ones in like a box of cellophane.
That weren't even coffee.
No, it was just like candy. Yeah.
That's literally basically.
Now I take those Ricola ones like honey lemon
Mhm.
because they're kind of like, well, okay. Let's say we want to do an experiment to test, do these cough drops work? How? Okay. First, what's your hypothesis? Do they work? You think what? No? Do you think they work, Isaiah?
No.
Okay. So, can you tell me that in a
Actually,
form of a hypothesis? You think yes? So, a hypothesis would be something like if a person takes a cough drop, then they will cough less times in an hour, right? That would be, could we test that?
Yeah.
Yeah, you could set that up pretty easily. But that's my hypothesis. I'm telling what I think. If a person takes this cough drop, then this will happen. What's the, in that experiment, what's the independent variable?
Cough drop.
Yeah, whether or not I would have two groups of students. Some I would give a cough drop, some I wouldn't. What would I have to make sure about with all my students?
They all have the same
Symptom.
Yeah, maybe I want them all to have some sort of like cold and they're coughing. Maybe I want them to be the same age.
or have the same amount of heat or
Yeah, there's lots of, you can think of,
because heat can affect it.
yeah, they'll be in the same temperature, sure. What's the dependent variable in this experiment going to be?
Or
Use a trial, but are the result.
The result, the data what data am I going to collect that's going to see if my hypothesis is right?
Number of coughs.
The number of coughs. I might count how many times each person coughs in an hour. That's my dependent variable. How would I have a control group? Remember,
Same room, same.
well, that's controlled variables. A control group is you got to compare. So one group, the experimental group, is going to get a cough drop. What about the other group?
there,
What should we do with them?
or they might get, or one group might get one cough drop, but the other might get two, maybe in an hour or a couple hours.
Okay, but that wouldn't be the control group. Because if I give both groups some cough drops and they work, that's not going to tell me what if they didn't have the cough drop? Would they have stopped coughing? I don't know. So I need a control group. Sometimes you give a control group something that's not actually medicine. Maybe you give them like a hard candy instead of the cough drop.
Like one of those.
Jolly Rancher.
Yeah, sure. You give them a Jolly Rancher, right? Because maybe it's not the actual whatever's in the cough drop. Maybe it's just sucking on a candy is going to take away your cough, and that would show us that if we
Or
did the
maybe
experiment.
it takes time.
Or maybe it just takes time. If both groups cough the same amount, does the cough drop work? No, right? So I would collect my data for an hour, record how many times each person coughs, probably average up those numbers, and then I would have my results. And I would look at the results, and that would tell me if my hypothesis is correct or incorrect. Okay. Any questions about scientific method? That's it for this packet for that.